Okay. We're going to get started on things. We are on page 8. Today, we are starting to talk about pyramids. So, pyramids, very similar to prisms in that the fact that they are named for their bases. The difference is they have how many bases? One base, and then they come to a point. The base being opposite side of the point. What is the name of this pyramid? Pentagonal pyramid. Now, when it comes to our pyramids, our lateral area is the area that is not the base. So it's the area of all of these sides. What do you notice about all these sides of my pyramid? They are triangles. In fact, when we are dealing with pyramids, we are going to deal with what are known as essentially a regular pyramid, which means that the point is directly above the center of the base. It's never going to be kind of off to the side. You can have pyramids that are kind of slanted off to the side. All of our formulas don't work the exact same for those ones. So we're going to stick with our regular pyramids in which the base is always going to be a regular polygon of some sort. It could be a triangle, it could be a square, but then the point goes directly above that center of that base. So, as a result of working with these regular pyramids, that means all 5 of these triangles are congruent to one another. If I want lateral area, I'm focusing in on the area of just these triangles. How do you find the area of a triangle? 1/2 base times height. So, first off, base of these triangles. If I call these the bases, when I fold it back up into its pyramid, the bases of those triangles are making their way around the edge of the base. What do you call the distance around a shape? Perimeter, which means when I do my 1/2 base times height for the area of those triangles, the base could be the perimeter of the actual prism's base. Now the height of the triangle becomes a little more tricky, because if I look at the height of the triangle, if this is my base, the height has to go up here, and when I fold it back in, that's going along here. It's going at a slant. It's what's known as slant height. In this unit, we introduce a new variable, which you'll often see written like this. It's a fancy lowercase l. You can just draw it as a regular L as long as you know it's an L and not a 1. That's why they do the fancy L, so that it doesn't end up looking like a 1. And it represents what's known as slant height. Because with pyramids and with shapes that come to a point, there is the true height, the altitude, or the height of the pyramid, which goes from the middle of the base up to the point through the middle of the shape. And then there's that slant height that goes down the side. And to find the area of all of these triangles, we would need to use that slant height as the triangle height. Which means if I want just the lateral area would be 1/2 capital P fancy lowercase l, where P, again, is that perimeter of the base. How often are we going to use just the lateral area formula? Never. But I show it to you because it is a key thing that comes up at times on standardized tests, but they'll generally give you the formula. Being that it is an area, it would be units what? Squared. Now, much like with prisms, there are two surface area formulas. One, which we will for the most part never use, and you'll see me just kind of cross it off. A second one that we actually will be the one that we use. Now, surface area is the area of all the shapes put together. The triangles make up the lateral area. What's the only other thing we're missing? The triangles and then the base. So, the one we generally won't use is this. For a pyramid, add the singular base and the lateral areas, and that will be your surface area. But generally speaking, we're going to use this one. Because why not use the one that actually gives us all the information? What kind of units for a surface area? Units what?
Cube.
Surface area.
Oh, square.
It's still square. Now, volume of a regular, or it's also known as a right pyramid sometimes. When it comes to our pyramids, the kind of fun thing about our pyramids is our pyramids, if they have the same base, congruent bases to a prism, does this prism and this pyramid have the same size base and shape? Exactly the same? Perfect. And if they have the same height, would you say they have the same height? Then I could have created this pyramid by just chopping away parts of the prism. How much of the prism do you think I would need to chop away to make the pyramid? Half of it? Does everyone agree with half? Is that your guess? Best guess you got. Now, the point of this is that when it comes to calculating the volume of a pyramid, is it's very similar to calculating the volume of a prism. The only difference is that part of it's been cut away. But how much? Oh, this bucket might not be quite high enough to do this with. It's going to be a challenge. We're going to make it work. It's fine. Okay, one pyramid dumped in. Does that appear to be about half full?
Almost. About a quarter.
Almost? Maybe about a quarter? Yeah. Okay, so one pyramid fits within the prism. Because remember, volume is the amount of stuff that you can fill the shape with. Now, this is not perfectly full, so it might be off a little bit. Two pyramids in. I definitely didn't cut it in half because there's still leftover space, isn't there? So let's see. If I keep filling it. Now, save for the fact that I didn't fill it perfectly, would you essentially say that's full?
Yes.
And had I filled it perfectly, it would have been full.
Yes.
How much of the prism did I have to cut away?
3 times.
There were 3 times I filled it up, and therefore, I was left with 1/3 of it. How do you find the volume of a prism? What's the formula for prisms? Volume equals what? Base times height. A pyramid is 1/3 of that. To find the volume of a prism, 1/3, or of a pyramid, 1/3. Base times height. Where base, we're talking base area, not just base length. Remember, capital letter means it's something you're actually going to have to calculate. You can't just look at the shape and say, ah, that's what it is. What kind of units are going to go on a volume? Units cubed. Okay. By the way, I could have done the same thing with the triangle. It's always 1/3. Okay, much like yesterday, much like the day before, much like the day before that. First things first, identify the shape. What have we got here? Pentagonal pyramid. If you haven't figured this out by now, the name tells you a lot about the shape. The first word tells you about how to find the base area, tells you about the base. The second word tells you about what formulas apply to that three-dimensional solid. Being a pyramid, I want to find volume and surface area. That means my formulas are this. We just wrote them down. Much like before, you will see me generally pull off the base. The base is what shape in this one? It's the pentagon. That is my base. So that is what I'm going to pull off. I'm going to mark what I know about it. I know those, I know that. Oh, and it appears to have something from here to here. 6.2, okay. That's everything I know about that base. According to what's over here, I need capital B and capital P from this base. Hey, that sounds familiar, doesn't it? It's almost like we did that for prisms. Capital B is base area. To find the base area, I have to recognize what formula works for this shape. We said this was a pentagon. What formula works for our pentagons? She still has my formula sheet. Go down your list if you don't know. Is it a triangle? Is it a parallelogram? No. Is it a circle? Is it a circle sector? Chitorhombus? Trapezoid?
No. 1/2.
Regular polygon?
Yes.
1/2 ASN. One half times, what's A? 6.2 is our apothem. What's S? 9. Side length is 9. What's N?
6.
That's the 5. Because it's a 5-sided polygon.
5.
I didn't do a calculator.
For some reason, my regular polygon has 6 sides. And that I drew.
You drew it wrong.
Yeah, I know.
I got 139.5.
139.5 it is. Actually, I don't know that, so I'm just trusting you. Is that the only thing I need from the base? Look at these formulas. Are any of these things also about the base? Found that. Is P about the base?
Oh, yeah.
Of base. Of base. Okay, so I need to find the perimeter. How do I find the perimeter? Add up all the sides, or on a regular polygon, they're all going to be the same. 9 times 5. 45. I wait to put my units on because I can. I go back to what I was doing. Starting with this. S equals base area. 139.5 plus 1/2 times P times. Here's where we have to start to be careful. Because as I mentioned before, when it comes to these shapes that come to a point, there are 2 different types of height. There is true height, altitude, and there is slant height. L stands for slant height. Slant height will go from the vertex that is opposite of the base, so from the top corner, and it will go down the side of the shape to the side of one of the base sides. Yes, in this one, this is our slant height, because you can see it going from the tip down the side of the shape. I did not give myself enough room to write this. This is how big I write. It's not the prettiest formula, but guess what? It's calculator friendly. If you choose to do it in pieces, what things do you have to do first? Yep. By order of operations, what operations have to go first in this formula?
45 times 13.5.
Times 1/2.
That's right.
These 3 have to be multiplied before you go doing any sort of adding. You can multiply them in pieces, you can multiply them all together, I don't care. I personally just put it all into my calculator and say, calculator, do good things. And I do 1/2 as 0.5 most of the time, because it's easier. 443.25.
I got that.
Beautiful. 443.25 is surface area. Before I am done with surface area, I make sure that I do what? Units. What kind of units? Centimeters squared, because it's a surface area. Am I done with my problem?
No.
What have I not done?
Volume.
Volume. It asks for 2 things, 2 answers. Volume equals 1/3 times 139.5 times H. In other words, true height. This one has to go from tip down to the center of the base.
13.5.
Not 13.5. That one's slant height.
Oh, wait. 6.2?
12
Oh.
goes from tip
Oh,
of the
okay.
down. Now, granted, I say down, assuming the pyramid is standing straight up. Do pyramids always have to stand straight up?
No.
No, they can fall down. If they fall down, let's say it's sitting on the table. Now, under the dot cam, I can't really show the table very well, so let's imagine this was the edge of the table and it was sitting like this on the ground. Slant height goes from tip to the edge of the side. It would go along here or even go along here. And true height would go from here to the center of the base. So you would see it dotted through here. So you got to be careful. Look where the vertex is getting connected to. One third is not like 1/2 in the fact that it comes to a nice decimal that you could just put into your calculator. Because what is 1/3 as a decimal?
125.
No, that's 1/4.
Oh wait.
0.333333333. When do the threes end?
Never.
Never, which means you cannot put a decimal in this place. It has to be the fraction. How do I put 1/3 into the calculator? 1 divided by 3. If you like putting it in parentheses just to make sure, you can. If you don't, in this case, it won't make a difference. As long as you make sure to put the time symbol and don't do what I just did. Times 39.5 times 12.
You could also just make the 1/3 into a fraction. Like your calculator.
There's a fraction.
Not all calculators have a fraction
Oh,
button.
okay.
558.
Yep.
Yep. Oh, centimeters cubed.
Centimeters cubed. Beautiful. Flip the page. Isabel, what type of shape do I have going on here? I'll give you the triangular, but it's not a prism. It is a pyramid, but I heard prism.
Why isn't this a prism?
Prisms have to have two congruent and parallel bases. It's got a bunch of triangles, but none of them are parallel to one another. Instead, it comes to a point. So, triangular pyramid. Okay, being a pyramid. Surface area equals... Charlie, what's that formula for surface area of a pyramid again? It's on the other side of your notes back. We haven't gotten it onto the note sheet yet unless you specifically wrote it. What is the formula for surface area? Base plus half of PL. Cam, what about the volume formula?
Base times height, 1/3.
1/3 base times height. Brody, after I've identified those formulas, what do I typically do next? I've always been writing kind of here.
The base, draw the base.
I draw out my base. While it's not a required step, it helps a lot of people see what's going on. Base. That's my point. This one. Triangle. Poorly drawn. Okay, that's 8. That's 8. Ooh, that's 8. Do I have anything else about that triangle?
Middle part, 6.9.
6.9. Ava, how do I find the area of that base? How do I find the area of this shape?
I
What shape is it?
Oh, tried. Oh, 1/2 base.
I knew you knew it. Haley, what are the base and the height of this triangle? Yes. Base is 8, height is 6.9. Specifically, this is the base of the triangle, this is the height of the triangle. So 1/2 times 8 times 6.9. 28 point something? Dang, 27.6. Greta, what other piece of information do I need from the triangle?
Down the middle.
I'm sorry, what was that?
Set the line down the middle. For like the second part.
This one? That helped me get this. I meant like what other thing do I have to calculate from it? I find its base area and I also find its,
Volume.
not from the triangle, perimeter. Capital letters I calculate before I get back to these. Yes, I do want to find the volume of the prism in the end. Jocelyn, what's going to be the perimeter of my triangle? Yeah, 8 plus 8 plus 8. Okay, so surface area equals B, we just found to be 27.6, plus 1/2 times P, we just found to be 24, times Lily, what is L?
8.3.
Yes. This is L. L is slant height. Again, has to go from the point of the pyramid down the side of the shape. So it is 8.3. Connor, what do you get for that? What do we get for this? Do the calculation, please. Yup. Trey, 127.2 what? Inches squared. Okay, volume 1/3 times base area we said was 27.6 times Dominic, what would be H? Be careful. This H and this H are two different H's. This is the height of the triangle. This H, I want the height of the pyramid. The height of the pyramid goes from the point of the pyramid down to the base. 7.55. This is our H because of where it's located. Nate, what do we get for that? Calculator. 69.46 watts.
Which is cute.
We got 2 more total problems. The first one is gonna look very similar in many ways. There's a tiny difference that happens with this one. We start the same way though. We identify the shape of it. Kylie, what shape is it? Rectangular pyramid. Is there another name we could have called it? Square pyramid. Technically both are appropriate. I generally stick with rectangular pyramid. Being a pyramid, guess what? Same formulas. Base is that rectangle. From the base, I need base area and base perimeter. Elena, how do I find the area of a rectangle? Because a rectangle is a parallelogram. Base and height are 5. I don't think I'm surprising anyone with that. To find the perimeter, add up all the sides, but all the sides are going to be 5. So you can also use the S times N formula when the bases have all the same side lengths. I don't care which way you do it. Either way, you're going to get 20. So, I look at my surface area formula. I do 25 plus 1/2 times 20 times. What's the slant height?
We don't have it.
We don't have it. The slant height of this pyramid should be right here. But it's not. When you are missing something, and it's not a find the missing dimension problem, that's different. What shape do we typically use to help us? A right triangle. Do you see a right triangle in this picture?
Yes.
Pyramids will make right triangles, connecting the slant height, the true height, and technically there's an apothem there. If I had looked at this one, hey, right triangle. If I had looked at this one, hey, right triangle. So pyramids have built-in right triangles that we can work with. If we're missing either the true height or the slant height. So if I take that right triangle aside, I've got the right angle. That is the true height. That's 6. I don't have any other measurement, but here's the nice thing about the fact that that base is a square. If this is a square, then the distance to the center of it is the same as the distance to the center over here. It's going to be half of the side length. It only works on rectangular prisms. Sorry, not prism, pyramid. Other times that distance is going to be straight up given to you. It's only with the rectangular ones that they don't always put it. I'm going to put an X here, that's my slant height. Which side is my hypotenuse to do Pythagorean theorem? Yes, it's the X. So 6 squared plus 2.5 squared equals X squared. Do you trust my Pythagorean theorem skills? Colin, go ahead and calculate it on your own then.
Oh. ...
X is equal to 6.5. If you're gonna tell me no, you're gonna calculate it on your own.
Yeah, I got 6.5.
Okay. That was actually our slant height, our L.
Yeah, I got that too.
So that goes there.
Good job, Colin.
So sometimes you do need to go through and calculate either a true height or a slant height using the triangles, the right triangles that can appear. In this case, it gives me 90 as a surface area. 90 what?
Meters squared.
Meters squared.
I like having all this room.
You don't have quite this much room on the homework though, but yes, I like having the room. Volume being base times height is 25 times 6. 6 is the true height of the pyramid. You're gonna get 50. Meters cubed. Okay. We are almost done. The last one's gonna go pretty quick. Last one looks a little bit more like what we did yesterday, because throughout this unit you are going to get missing dimension problems, and I promise they don't require your cell phone. So when it comes to a missing dimension problem, just like you were doing on the other ones, you look at the shape and you say, okay, what shape is it? Triangular pyramid. Because that tells you what type of formulas you're going to use. It tells you that given that it's a pyramid, you've got either this formula or you have this formula to work with. Oops, 1/3. 1/3. Which formula do you think we're going to use given this pyramid?
Probably volume since we're.
They tell us V, so the volume formula is what we're going to be using. V was 384 equal to 1/3 times. Do we know the base area? Can we calculate the base area? Yes, the same way we did before. We pull off the base. The base on this one is a skinny looking triangle. I know that's 24. I know from here to here is 8. How do I find the area of a triangle? One half base times height. What are the base and the height?
24 and 8.
24 and 8. They're perpendicular.
192.
I was about to say. 96?
Yeah.
That works out better. Do I need to find the perimeter of the base when I'm just working backwards?
No, because it doesn't ask for it.
Doesn't ask for it in this formula. If you were using a surface area, then you would. 1/3 times 96 times. They've got H on that. How do I solve such an equation? What should I do first?
The third 96.
1/3 times 96. Be careful. Make sure you're doing the correct operation. It is indeed 32. 384 is equal to 32. Is it times H or plus H? It is times H. I ask that because one of the common things I'm still seeing a couple people do lately is subtracting the 32. But if it's times, what do? Divide. 384 divided by 32 is 12. It is a height, which means its units are regular units.